kind of what we did last week with simplifying the rational expressions, except yeah. So we're just doing rational expressions again.
Okay.
So x plus 2x, x squared minus 2x over x squared plus 2x plus 1 multiplied by x squared plus 4x plus 3.
The whole thing multiplied or just the denominator?
The whole thing.
Multiplied by what?
No, it's like the denominator, so just like the multiply sign and then another fraction.
I'm confused. What goes in the numerator and what goes in the denominator?
Well, so x squared plus 4x plus 3.
Where's that go? In the numerator or the denominator?
The numerator.
X squared plus 4x plus 3? Like that?
Yeah. But you don't need any, like, brackets.
Parentheses are as good as brackets at this point.
Okay. And then it's over x squared plus 3x.
All right. So we have multiplication of two fractions. Is that correct?
Yeah.
And I have them right?
Yes.
Whenever you see a problem like this, it is a factoring problem.
Okay.
Okay? Just always know that every term here can be factored. So factor the top left. Let's start there. What's the greatest common factor?
X.
What's left over?
2.
No. Remember that what's left over has to multiply by x to give you what you started with.
X. And then minus 2.
Okay. Notice, and you should always do this at every step of the way, check your answer, make sure that you have what you started with.
Okay.
Okay, now factor the bottom.
So it'd be 2 brackets, and then x in each. So it'd be x plus 2, x plus 1.
Remember the two numbers have to multiply to 1.
X plus 1, x plus 1.
And that produces the correct middle term of 2x. So that is correct. Okay. Now factor the top, right? Like I said, these are factoring problems and that's all they are.
Okay. So x in each bracket. X plus 3, x plus 1.
Factor the bottom.
So x multiplied by, and then would it just be 3x?
Remember, your answer has to equal that. So if I were to write what you said, that equals 3x squared. That's not right. Whatever you write inside the parentheses has to multiply by x to give you that. So what does it have to be?
3 times 1.
How about x plus 3?
Oh, okay, yeah.
Okay, now here's the way you get it. You take your term and you divide it by x, each one. Well, that divided by x is x. That divided by x is 3. So that's how you come up with it. Okay. Now start canceling. These are always canceling problems.
Okay.
What can I cancel?
X plus 3. And then x plus 1.
Okay. Now when I say cancel, that means replace it with a 1.
Yeah.
In other words, I can divide top and bottom by x plus 3. And that
Okay.
leaves a 1. Okay.
And then
One of the x plus 1s. Okay. What else?
the 2 x's.
Okay. What's that leave me with in the top?
X minus 2.
What's it leave me with in the bottom?
X plus 1.
Here's your answer. So these are strictly factoring problems, and then you cancel whatever you can cancel.
Alright.
Canceling is easy. It's the factoring that's tough.
Yeah.
All right. What else?
So 5x squared minus 20 over 25x squared, and then multiplied by x squared plus 10x plus 24, and then over x squared plus 6x plus 8.
All right. Again, a factoring problem.
Yeah.
Factor the top left.
So would you start off with an x?
Well, always look for greatest common factor. Always begin your factoring process with greatest common factor. Is there a greatest common factor there?
Would it be 5?
Uh-huh. What's that leave?
So x times plus 4
X squared minus 4.
minus 4.
Now, that happens to also be factorable. So what does x squared minus 4 factor into?
X plus 2, x minus 2.
Yeah. And that's always critical. You want to factor it down completely, because sometimes we may end up with a factor of x plus 2 or x minus 2 in one of these other terms.
Yeah.
You can cancel. The whole point here is to cancel. How about 25x squared?
Do you just leave it as the same?
Well, yeah. For the moment, let's do that. Factor the upper right.
So would it be x plus 4, x plus 6?
Factor the lower right.
And then x plus 4, x plus 2?
Now cancel wherever you can.
X plus 2, x plus 4.
Where else?
Would you do the 5 and 25x squared, or the 5 and 20?
Yes, for sure. You would definitely would. You would simplify that.
So would the bottom just be 5?
Uh-huh. Now, what do we have left?
X minus 2 and x plus 6 on top.
Times x plus 6, yeah. All divided by what?
5x squared.
And that's it. You can't really break it down any further than that.
Okay.
In other words, I could multiply the numerator, but that doesn't help because I get x squared plus 4x minus 12 all over 5x squared. I cannot simplify that any.
Yeah.
So it's better to leave it in factored form. Always remember that factored form is better, and only if you can do something with it.
Okay.
In other words, if somebody were to give me this answer over here, I would not factor it because I can't do anything with the factored form. But if somebody gives me the factored answer, I'm going to leave it like that.
All right.
Because factoring it doesn't, or multiplying it together doesn't really help. I can't really do anything with that.
Okay.
What else, Lackland? Yeah.
Yeah. All right. 1 over x plus 2 plus x over x squared plus x minus 2.
Is that an equation? Is it equal to something, or is it just an expression?
It's just an expression.
Okay. So, again, a factoring problem.
Okay.
So the only thing that can be factored is that right denominator.
Yep.
Factor that.
So x minus 2, x plus 1.
X plus 2, x minus 1.
Okay.
Remember, the signs have to be opposite. That's the only way you can produce a minus 2.
Okay.
And making the signs opposite produces the middle term of plus x, which is correct.
Yeah. Okay.
Okay. Now, we're adding two fractions. How do you add two fractions?
Do you add a cross?
You have to come up with a common denominator.
Okay.
What is the common denominator here?
X.
No, it's the denominator that is divisible by both terms. In other words, I need a common denominator that is divisible into both of these terms.
2.
No, it's this term right here.
Okay.
In other words, my common denominator is x plus 2 times x minus 1. And that's going to be my denominator for both terms. Now, the reason that is the common denominator, well, we'll get to that in a second. What goes in the top left?
1.
Whatever goes in the top left has to make that fraction equal to that fraction. Top left again.
X plus 2.
How about, you're close, x minus 1. Notice that if I put x minus 1 in the numerator, then this x minus 1 cancels with that x minus 1 and I don't change it. That is the key. You do not want to change that fraction.
Okay.
Okay? The thing in the bottom is the same fraction as in the top. In other words, if I were to start with the bottom, I would cancel the x minus 1s, and I would end up with 1 over x plus 2.
Okay.
Now, what goes in the upper right such that that is the same as whatever I'm going to put in there.
Would it be x minus 1?
How about x? That's the same.
Okay.
Do you see why that's the same? That's the same as that.
Yeah.
That's what you want to do, is you want to make it the same. Now in this case, it was truly the same. But over here on the top left, that is also the same as that.
All right.
So whenever you're adding fractions and you're coming up with a common denominator, and it's harder with variables than it is with numbers, for sure, but just do it and make sure you don't change it from step to step.
Okay.
Now, I have the bottom. How do I add those two fractions? First of all, what's the denominator?
X plus 2, x minus times x minus 1.
Correct. Now remember, you operate on the numerators. The denominator stays the same, but you go ahead and perform the operation on the numerators. Well, what's the operation on the numerators result in?
X squared minus 1?
No, you're adding, you're not multiplying.
Oh, so 2x minus 1?
2x minus 1, exactly. In other words, I have one apple there, I'm adding another apple, I got 2 apples.
Yeah.
And I still have a minus 1. Now, can I simplify that?
No.
No, you can't. In other words, even though I'm looking at an x minus 1, I cannot do anything with that 2x minus 1. If that was an x minus 1, I could cancel it out with this x minus 1. But it isn't. It's a 2x minus 1. So that's as simplified as I can do.
Okay. Alright, so x over x squared minus x minus 30. And then, minus 1 over x plus 5.
Okay. Again, always look to factor as your first step.
Okay.
So the only term here that can be factored is this one.
Yeah.
So let's factor that.
Would it be x plus 6x minus 5?
It's x minus 6x plus 5.
Oh, okay.
Now, this is the second time you've made this mistake, so let's examine this. We have to have the combination of the middle terms, the inside and the outside of FOIL, equal minus x, the middle term up here.
Okay.
Well, minus 6x and plus 5x results in that.
Yeah.
If I had plus 6x and minus 5x, then I would have a plus x as a middle term. And I don't. I have a minus x. So it very definitely has to be minus 6x and plus 5x.
Okay.
In other words, whenever you're checking your factoring, just multiply the inside and the outside and see that you get the correct middle term. Well, that is the correct middle term.
Okay.
That means I've factored it correctly.
All right.
Now, doesn't get any easier yet. What's the common denominator?
The x plus 5.
No, it's this. Remember what the common denominator means. It means a denominator that will divide by each of these terms evenly. Well, if I divide by, I'm going to call this the common denominator, okay?
Okay.
Well, I can certainly divide that by that. It's equal to 1. And I can divide it by that. It's equal to x minus 6.
Yep.
So that makes it a acceptable common denominator.
Okay.
And it has to do that. In other words, when you come up with your common denominator, let's say you're dividing one or subtracting 1/4 times 1/3. What's the common denominator there?
1/4.
12. It's the product of those two denominators.
Okay, yeah.
Okay? And the way we get the numerator here is to divide 4 into 12 and we get 3. Well, that's the same as 1/4.
All right.
And the way we get the numerator in the top right is to divide 3 into 12. We get 4.
Yeah.
Well, 3/12 minus 4/12 is minus 1/12.
Okay.
That's how you divide fractions and how you get common denominators.
Yeah.
Okay? So, back to our problem. We have our common denominator. What's the top left numerator?
So.
Remember one thing. You do not want to change that. Whatever that says, you want that to be the same.
So. I'm kind of confused.
Well, what would make those two fractions the same? What numerator?
X.
That's it. In other words, that's the answer for the top left.
Okay.
Now, on the top right, what would make that the same as that?
1.
Would it? Would 1 over this be the same as 1 over x plus 5?
No.
No. What would it be?
X minus 6.
You got it. In other words, that the top right is the same as the bottom right.
All right.
Do you see that?
Yeah, I
In
do.
other words, as long as I put parentheses around it, then the bottom right is the same as the top right.
Okay.
Okay. Now we have a common denominator. Now that we have a common denominator, we can operate on the numerators. So my common denominator, I don't want to multiply these together. Always leave these unmultiplied. Like
Okay.
that. What's the top become?
2x minus 6.
Okay, the top is x minus 6, right?
Yeah.
So remove the parentheses first. What does that become?
X x minus 6?
This minus sign has to be applied to that number. So it's x minus x plus 6.
Okay.
What's x minus x?
Not 0.
Okay. So the only thing left is a 6.
Okay.
There's your answer. And
Alright.
that's what you want to put as your answer. You do not want to multiply the bottom together.
Yeah.
Factored answers are better than non-factored answers.
Okay.
At least to the point where you don't want to multiply them together to come up with another answer. Sometimes if you have it in the form of the quadratic that would result from multiplying those, you don't need to necessarily factor it, but if it's in a factored format, don't multiply it together. There's no advantage in doing that.
Okay.
And there is some advantage in leaving it in a factored format. We don't know what the next step of that problem might be, but whatever it is, it's going to be better with that answer in a factored format than a non-factored.
Okay. Alright. 1 over x cubed plus 10x squared, and then divided by x squared minus 9 over x plus 3, and then multiplied by x.
Hold on, I'm not sure what happened. What the heck happened? My phone went off and my computer screen reacted. Okay. Multiplied by what?
So then multiplied and then x plus 10. Oh no, it's like a new fraction for x plus 10.
Up here?
So then, yeah. So then multiplied by x plus 10 over x squared plus 7x plus 12.
Okay. First of all, let's talk about the difference between multiplication and division.
Okay.
How do I turn this into a pure multiplication problem?
Don't you flip the equation, the x squared minus 9 over x plus 3?
Yeah, that's all you have to do.
Okay.
So this whole thing turns into this. Multiplied by x plus 3 divided by x squared minus 9 multiplied by x plus 10 over x squared plus 7x plus 12. Now it's pure multiplication.
Okay.
What's the next step?
So you factor, right?
Okay, factor wherever you possibly can. Well, I can't factor 1.
Yeah.
Can I factor the bottom? Think greatest common factor. Always start there.
So it'd be x times.
What's the greatest common factor that you can take out of that expression?
X.
X squared.
Okay.
What's it leave?
10 and x.
X plus 10.
Okay.
Now, before you go to the next step, make sure you multiply these two together and you get what you started with. Do you?
Yes.
Then you've done it correctly.
Okay.
That's always the next step. Always check along the way. Because you're talking here about a 10-step problem. If you get to a final answer and it's not the correct one and you try to figure out where you went wrong, you got to go all the way back to the beginning.
Yeah.
So by checking along the way, you accomplish a lot.
Yeah.
All right. The bottom, what do you call this x squared minus 9? There's a name for that. And it's useful to remember it. I call it dopes.
Oh yeah, dopes. Different perfect
Squares.
squares.
Difference of perfect squares. Well, how does that factor?
X plus 3 times x minus 3.
Now let's go to the term on the right. That x plus 10 certainly doesn't factor, but the bottom does. What's the bottom factor into?
X plus 4, x plus 3.
Yep. Now start canceling wherever you can cancel.
X plus 10. And then x plus 3. And I think that's it.
Yeah, so what does that leave us with?
So,
Left in the numerator.
1.
Okay, hold on a second. My computer's going a little bit nuts here. Don't know why, but yeah, you're right. 1. Yeah.
And then over x squared times x minus 3 times x plus 4.
Go in order, left to right. Nothing happened to this x plus 3. It was this x plus 3 that got canceled.
Yeah.
So I still have an x plus 3 there.
Okay.
And I still have an x minus 3. And I still have an x plus 4. That's why I say go left to right. Don't jump around.
Okay.
That's your answer. You don't want to multiply those together either.
Yeah.
In other words, first of all, that would take a lot of work. That'd take another 10 minutes to multiply all those together.
Yeah.
And again, factored answers are better than unfactored. This is factored. That's going to be, if I were to multiply everything together, I would have a x to the 5th polynomial, which would be very difficult to factor. And a lot of times, whatever the next step is, it's going to be helpful to have that factored. So I leave it factored, always.
All right.
Okay. What else do you have?
So that's the whole worksheet now.
That's it? You don't have any other problems?
No, but I have math homework now, like a separate thing.
Okay, let's do that. And we don't have to necessarily go the entire hour. If you only go 45 minutes, we can stop, and I'll only charge you for 45 minutes.
Okay.
But please do everything you need to do. In other words, don't stop short if you still have questions on some problems.
All right. So it says solve the quadratic below twice, once by factoring and using the zero product property, and once by completing the square.
Okay.
So the equation is x squared plus 14x plus 33 equals 0.
This is because we're going to do it in two different manners.
Okay.
Solve it by factoring.
So x plus 11 and x plus 3.
Okay, that works. What's the answer here? X equals what?
0.
No, that's equal to 0, and that's equal to 0. But x is not equal to 0. The fundamental rule of algebra is if you're multiplying two entities together and they're equal to 0, then one of those entities, by definition, has to be equal to 0. So I
Okay.
know that x plus 11 has to be equal to 0, and so does x plus 3, which makes x equal minus 11 and x equal minus 3. Those are your two solutions.
Okay.
Because that I set to 0, which produces the first solution, and that I set to 0, which produces the second solution.
All right.
Now let's complete the square. Well, when you're completing the square, that was the second way they wanted you to do it, right?
Yeah.
When you complete the square, you want to put the number on the other side. The most important thing to do when you're completing the square, or for that matter, on most all algebra problems, is you don't want to change the equation from step to step. Are both of those the same?
No.
Yes, they are.
Oh, yes.
In other words, is all I did was subtract 33 from both sides. With me?
Yeah.
Okay. Now we can put a parentheses around that, and I can complete the square inside the parentheses. And the method for completing the square is you take half of that and square it. What is
So
that?
7 squared?
Plus 49. Now, I just changed so that row 2 is no longer equal to row 1. What do I have to do to the right side of this equation so that they're still the same? I have to add 49 also. In other
Okay.
words, I added 49 to the left side, I got to add 49 to the right. Now, that is perfectly equal to that. And that's a key part of completing the squares. You never want to change it. The only reason we complete the square is so that I can now represent this as x plus 7 squared. You're always going to be able to represent it as a linear term squared. Binomial linear term squared. That's the only reason we complete the square. Okay?
Okay.
The right side is 16, right? In other words, I got to add those two numbers together.
Yeah.
Now I can solve this problem by taking the square root of both sides. Well, what do you get when you take the square root of both sides?
Of the bottom equation?
Well, start with taking the square root of that.
X plus 7 and x plus 7?
Square root of that is x plus 7.
Oh, okay.
Now take the square root of 16.
4.
All right. This is a mistake that about 95% of my students make. And I don't know how to get you to fix this in your memory. I wish there was a song like the ABCs, or I know they teach a song for the quadratic formula. I've never heard a song that works here. But here's my song. if you're going to solve an equation by taking the square root of both sides, always, always, always begin your answer with the words plus or minus. It's plus or minus 4.
Okay.
Notice that plus 4 times plus 4 is 16. Also,
Yeah.
minus 4 times minus 4 is 16.
Yeah.
That's why minus 4 is part of the answer.
All right.
Remember, we better get the same answer as we got with the other method. So, if I'm solving for x here, I'm going to move the 7 to the other side. You with me?
Yeah.
Now, there's two solutions. One is the plus, one is the minus. What's the plus solution? In other words, when you do that, what do you get?
-3.
When you do this, what do you get?
Negative. Would it be 11?
Notice those two solutions are the same as the two solutions we did or we got when we factored it. Now,
Yes.
it's the same. It better be the same. Math's always the same. You may have two different ways of doing something, but they better result in the same answer. If they don't, one of the methods is incorrect. That is the beauty of math. There is no subjectivity to it. There is one correct answer and one correct answer only.
Yeah.
Well, when we did it by factoring, we got that. That was what? 3 steps? 2 steps?
Yeah.
When we did it by completing the square, it was 1 step, 2 steps, 3 steps, 4 steps, 5 steps. So, which way do you want to do it if you can do it?
The left way?
Factoring way.
Yeah, factoring.
Yeah. Now, you can't always do it the factoring way. In other
Mm-hmm.
words, this was a unique problem in the fact that 11 times 3 was equal to 33, and those two numbers added to 14. So I was able to do this the factoring way. But make
Yeah.
that number 32? Can't do it factoring.
Yeah.
However, I would still be able to do it by taking the square root of both sides.
Yeah.
So this is the more powerful technique, even though it's the longer technique in a lot of problems. It all depends on whether you can factor the quadratic or not. If you can factor it, and by factoring it I mean into integers. That's an
Okay.
integer, that's an integer. If you can factor it, it's usually going to be quicker to solve it that way, 3 steps versus 6 steps. But the 6-step formula will always work 100% of the time. Whereas the factoring method only works when you happen to have a number here that fits the rules perfectly. In other words, you have to have factors of that to add to 14. If you don't, it's not going to factor.
Yeah.
So this demonstrates a lot. Shows you that completing the square is the longer way, but it also always works.
Yeah.
In fact, let me do one real quick. That does not factor.
Yeah.
I would need factors of 10 that subtract to the number 1. They don't exist.
Yeah.
So I can't factor this. But I can solve it by taking the square roots of both sides. And the first thing I need, or completing the square rather, and the first thing I need to do is take that constant onto the other side. So this is the first big difference, is that normally you want everything on the left side and 0 on the other. But if you're going to solve a quadratic by completing the square, you don't want that. You want the number on the right side, all the x terms on the left.
Okay.
Now, complete the square there. The coefficient of the x term.
So it'd be,
That's the first thing you got to figure out, is the coefficient of the x term. What is it?
squared?
1.
1.
There's always a 1 there, even though it's not written.
Okay, yeah.
What's the coefficient of the x squared term?
1x squared?
Okay. Yes. In other words, just because you don't see a coefficient doesn't mean it's not there. It's 1. Or if you have -1.
Yeah.
Now, take half of that and square it and add it. That's the method. Is you always take half the coefficient, square it, and add it inside the parentheses. Well, what do you get?
So would it be 2x squared?
What's 1/2 times 1/2? In other words, half the coefficient is 1/2.
Yeah.
Square
Okay,
it,
so
multiply it by itself. What is that?
1.
Multiply numerators and denominators. You have to distinguish between multiplication and addition.
Oh,
This is not addition. Addition would be 1. Multiplication is you're multiplying numerators and multiplying denominators.
so 2/4?
1/4.
1/4.
Numerators multiply to 1. The denominators multiply to 4.
Yeah.
Okay? So that's the first thing, is you definitely got to get your arithmetic in order. And you have to understand the difference between addition and multiplication. There's a huge difference. Huge. You can't mix them up. If you mix them up, you'll never go further than you are right now in math.
All right.
You got to be able to distinguish between multiplication and addition. Same thing between division and subtraction.
Yeah.
Subtraction and addition kind of go together. Multiplication and division kind of go together. But addition does not go together with multiplication. They're totally different.
Yeah.
When you're adding something, this would add to 1. When you're multiplying it, it multiplies to 1/4. Okay? Now, I just wrote in 1/4 on the left side of the equation. Well, that changed it, did it not? In other words, I did have it exactly the same as what I started with, but now I've written in 1/4. So how do I balance it?
Do you put it on the other side?
Yeah, I got to add 1/4 to the other side. Now it's the same. In other words, I could subtract 1/4 from both sides and get back to my original equation. Now, the advantage of completing the square, the whole purpose of it, is so that you can write this as this. In other words, you want to be able to write it as a linear term squared. You with me?
Yeah.
How do I solve that? Got one side being squared, the other side not. Think square root of both sides.
So, would the square root of x minus 1/2 be 1/4?
No. When you're taking the square root of something that's being squared, it's whatever the something is.
So, half?
That's the square root of the left side. Square root of the right side is that.
Alright.
Actually not that. It's plus or minus that. Remember, whenever you're solving an equation, by taking the square root of both sides, the first step is always plus or minus.
Yep.
Now, I'm still trying to solve for x, so I got to get rid of that 1/2. What do I got to do?
Add 1/2?
Yeah, and I'm going to put it in front. And there's a reason. And I'm going to call that 41/4. Same as 10 1/4.
Yep.
Now, this happens to convert to 1/2 plus or minus root 41 over 2.
Yep.
And that's your answer, remember, is the plus and the minus.
Alright.
There's two answers here. One of them is x equals 1/2 plus root 41 over 2. And the other answer is x equals 1/2 minus root 41 over 2.
Okay.
Those are the two solutions to the problem that I gave you. Now, I just created that out of thin air, so I'm not surprised that we had weird answers.
Yeah.
The only reason I did it was to show you that how to complete the square.
Alright.
And remember, the only reason you complete the square is so you can show that quadratic as a binomial linear term squared.
Alright.
So we got like 5 minutes, and unfortunately I do have a 4 o'clock appointment that I got to go to. So what do you got that we can do in 5 minutes?
I think that's pretty much it for today.
Huh? Okay.
So that should be good.
Yeah, we covered a lot today. We covered completing the square, which is a big topic, and factoring, which is another big topic. In other words, they could spend in a year-long algebra course, Algebra 2, they could spend 6 of the 9 months on factoring, and that would be appropriate. That's how important factoring is to algebra.
Okay.
You just can't be good enough at it. In other words, the more practice you get at factoring, the better. You should practice, practice, practice whenever you get a chance. If it's a factoring problem, practice it until you get good at it.
Yep.
There's nothing you could be better at than factoring that's going to help your grade.
Alright.
Okay? All right, Lachlan. I will talk to you at our next scheduled session.
Alright. Thank you.
You're welcome.